Hello everyone, in this TRICR tutorial number 74 we will review the main principle of the bipolar translinear circuit developed by Barrie Gilbert. The collector current IC of the bipolar transistor is controlled by the base emitter voltage VBE according to the equation IC equal IS exponential VBE over VT, where IS is the saturation current, which means the reverse current, and Vt is a thermal voltage equal to Kt over Q, where K is the Boltzmann constant and Q is the electron charge. The transconductance Gm is a linear function of IC, then the name translinear circuit. In this circuit, the four bipolar transistors Q1, Q2, Q3, and Q4 are connected as diodes, and each biased with their own bias current I1, I2, I3, and I4. From the current equation IC, we can write VBE equal VT log IC over IS. It is obvious that VBE1 plus VBE2 is equal to VBE3 plus VBE4. Now, replace VBE with its equation VBE equal VT log IC over IS. We can simplify by removing VT from both sides of the equation. Recall the main logarithm function log of A plus log of B is equal to log of AB. Equation 1 can be written as equation 2. Equation 2 is solved if I1 times I2 is equal to I3 times I4. In conclusion, the sum of the closed loop voltage is equivalent to the multiplying the current. We start with the bipolar current mirror Q1 and Q3 with an input current I in biasing Q1 and an output current I out supplied by the collector of Q3. The bases of Q3 and Q1 are powered by Q2. The current I2 biases transistor Q2. If we assume that Q1 and Q3 have the same emitter area, the current mirror has a gain of 1, so I out equal I in. The interesting point in this, if we now introduce an additional branch into this circuit with Q4 biased by I4, we will obtain a new circuit where we can apply the Barrie Gilbert technique to calculate the output current by summing VBE with VBE1 plus VBE2 equal VBE4 plus VBE3. VBE1 is related to the current I in, VBE2 is related to the current I2, VBE4 is related to the current I4, and VBE3 is related to the current I out. We can then replace VBE with the expression VT log IC over IS with their own current IC indicated in bold and dark blue. After removing VT, we can use the new logarithm expression, then the current expression I in times I2 equal I4 times I0. Finally, the output current I out is equal to I in times I2 divided by I4. With this simple circuit consisting of four bipolar circuits, we can obtain a multiplication and division of the currents. Of course, if I1 equal I2, the voltage VBE2 equal VBE4, then VBE1 equal VBE3, we will find the basic result of the mirror current since the base voltage of Q1 is equal to the base voltage of Q3. The basic general circuit shown here calculates I in times I2 over I4. However, the schematic can be simplified to represent a specific square function, for example by forcing the input current I in Q1 and Q2 in series. We calculate the sum of the voltages VBE, VBE1 plus VBE2 equal VBE4 plus VBE3. We then check which current is related to VBE. VBE1 and VBE2 are biased by I-in. VBE4 is biased by I4, and VBE3 provides the output current. We can then replace VBE with the expression VT log IC over IS with its own current IC indicated in bold and dark blue. We obtain the logarithmic expression, then the current expression I-in time I-in equal I4 time I0. Finally, the output current I-out is equal to I-in squared divided by I4. In this second example, instead of Q1 and Q2, the two bipolar in series as Q3 and Q4. We add the voltages VBE, VBE1 plus VBE2 equal VBE4 plus VBE3. We then check which current is related to VBE. VBE1 is biased with I-in and VBE2 is related to I2. But VBE3 and VBE4 are both biased by the output current I-out. We can then replace VBE with the expression VT log IC over IS with their own current IC shown in bold and dark blue. We obtain the logarithmic expression, then the expression for the current I-in time I2 equal I-out time I-out. I-in time I2 is equal to the square of the output current I-out. Finally, the output current I-out is equal to the square root of I-in time I2. I want to thank you for your attention. In my next ERICCAR tutorial number 75, I will show you a real application of these bipolar translinear circuits to correct the nonlinearity of the CGD capacitor. So, see you soon and stay tuned.